welcome to my second part of my lecture about LoRaWAN devices. And I very briefly discussed the part about power consumption and energy consumption of LoRaWAN devices. But because this is such a vital part of LoRaWAN, because it's actually crucial to many IoT use cases, I invited an expert to talk a bit more about this specific part. So I got with me Vanja. Vanja is the CEO and founder of Koitech, which is a Swedish-based company which does a lot of highly advanced energy analysis. And yeah, so welcome, Vanja. You want to say a few more words about who you are and what do you do?
Yeah, thanks. Thanks for having me. So we at Koitech strive to develop tools that will help anybody in the stack to work with energy optimization. And in contrast to what many of you probably have seen in a university lab or a company lab, we are actually doing something that is easy to use, still very comprehensive, but very easy to use for the developers. We think the developer tools are a major part of energy optimization and getting that longer battery time. And you have probably seen our product OTArc throughout the LoRaWAN community. It's extensively used. And this is a simple setup that I'm going to show here how it looks like. In this case, for example, we are measuring a generic node, the Things Network generic node that we have had in our lab testing. And the setup is very simple. And OTArc is a power analyzer, power supply, and log sync all in one, something that every developer needs on their table.
Perfect. All right, we're going to dive into your tool set in a bit, but maybe before we start. So quite often when I look on the internet, if I see my LinkedIn, then there are so many advertisements about LoRaWAN devices that promise 5 years, sometimes even 10 years of battery consumption. Is it actually feasible, or is this a kind of myth?
The simple answer is it depends. And I know it's not fair to say that, but it truly does. And I think one major thing, what it depends on, is the application in itself. So you really need to understand and know your application. What are you trying to do? It depends very much whether you are going to be sending the data very often, listening very often. Is it going to be in a certain environment? Is it going to be mobile or non-mobile? There's so many different aspects of it. And once you know what your application is, your normal application is, and then what are the kind of corner cases of it, you will then be much more fitted to get into the deep dive of the low power and the battery life. And to do that, then you need, I usually say, kind of three things. One is you need to really be very good at picking the technology, the right technology for what you want to be doing, and then the right components, obviously the low power one, and the settings, right, to do that. The second one is you need to have the engineering skills and testing. You really need to do that, and I understand that it's not something that it's something gained, with experience, but low power mindset is all about practicing and working on it. And then the third one is actually having the right tools to kind of help you throughout this, and not being limited, always having the insight in what is happening throughout the development project. Because when you start with something, throughout the iterative kind of ways of working in development, this will change, and you need to understand what has been changing, so you don't end up setting a goal, let's say energy budgets, and you're not meeting them. This is actually very common. This happens quite a lot. People having one assumption, and then at the end of the day, at the end of the project, they're not reaching them, and there are delays in the project, and there are issues there, and you don't want to end up there.
Yeah, so you say you need the hardware to support it, you need the mindset, and you eventually need the tools to test and develop.
Yes, that would be kind of the overall high level. Like, okay, if you think, I usually say that like the most good things come in three, right? So it's much easier to remember then.
Yeah, nice. Okay, this sounds very cool. But like, what does it mean in practice? So we dive into a workshop in a bit where students actually gonna go hands-on with devices. So yeah, like how would that work in practice?
Well, again, I will let me give you like three key best practices. One would be engineering your application and the technology components that you're picking. The second one would be engineering your device to sleep. And the third one would be to pick the right energy source for your application specifically. And if we go kind of digging into each of these, let's start the first one, engineering kind of around the technology and the system and the ecosystem you're in. For example, in LoRaWAN, you know that most of the power from the system perspective would be depending on the time on air and the output power, right? So assumably you would want to then be spending less time on air to not to consume much power, right? So you need to really understand how that works and how will that work in connection with your application.
So the less time on air, I guess that would mean either send less uplinks or use a lower spreading factor. Is that correct?
Absolutely, yeah. I mean, again, it depends a bit on what you want to be achieving. But I mean, for example, spreading factor is one of these key parameters that a lot of people are interested in, and they might not actually matter at all if you're choosing a device class that is continuously sending and receiving, right? But if you're in a class of device like a class A, then you definitely will have some benefits in kind of putting effort on what sparing factor is the best for you. And let me give you an example. For example, we have a measurement here. Let me just kind of bring it up. And what is interesting here is that we have a couple of these measurements, and we have done it with different types of the spreading factors. In this case, we have a spreading factor that is 12 and spreading factor that is 7. And of course, when you're talking about spreading factors, you would say the one that is longer on the air, you have more robustness to it, and you will get a little bit more coverage. But if you are on air, less of the time, you will obviously have much less of the energy consumed. And this is a perfect example now when you kind of overlap them in the measurement and see what the difference really is. But let me, for example, say this is typically a case here where you would say have a kind of a normal placement. It's quite nice, close to the gateway. You have maybe line of sight. Everything is fine. Everything's working well. But maybe you place another one somewhere else, and then you realize that, wow, I'm not getting any acknowledgements on what I'm actually transmitting, let's say, which means that you now have to repeat the message. And suddenly, for example, let me unhide here, and you will see that now the same message, even though you're having a spreading factor that is really low, you will expect lower power consumption. The repeating is obviously going to cause more power to be consumed. So here you really need to have these skills and know your application really well to understand how you're going to be setting these. And this is what I mean by kind of engineering the technology, understanding the technology aspect and what the technology itself can contribute with the actual low power, and then what can you do on your side, on your device side, to utilize this in a best possible way.
Yeah, exactly. Because it really looks like quite a significant difference, spreading factor 7 and spreading factor 12.
Yeah. So I would say that, I mean, if we go into that is from the technology and like kind of picking the right components. I mean, most of the components now are getting better and better and being low power, meaning that you would expect them to do their kind of work, but you have to see it also from the perspective of they might be used in different environment and different constellations, different contexts, and that means that you have to think about it. You can't just have one path with one user case. You have to have these corner cases as well. And if you go into the second kind of key practice is the engineering for sleep mode. Now, I think for the IoT, this is really feasible because most of the applications are such that you don't really necessarily have to be working all the time. And that means that if you can shut down things, if they're not making any sense or any purpose at the moment, shut them down. Don't have things working and draining the battery. And it is easier said than done, obviously. Especially now that, for example, you might have peripheral components out there on the board that are doing something that you're not really used to, or in the integration they're alive more than, or they're awake much more than you thought they would be. So you have to hands-on check that. So it's dividing things into subsystems, so checking them. But also it can be very simply, like a lot of microcontrollers manufacturers right now, they deliver a lot of things up and running per default, and that is to actually help developers, because most of the developers start by doing things, debugging things, testing things, and they want to have everything up and running. But you have to have in mind that eventually this is going to be a product, eventually you're going to go into production and you're going to release it. So you have to really make sure that you shut down everything. And I do have an example of that, actually. We recently measured that we were actually playing with a generic node on this specific topic. And it was, let me show here, for example, it is the case of UART being on. And UART is something that usually communications is used for debugging purposes. And it's something that will drain, obviously, current, because it's a data being transferred back and forth. So you have to be aware of that when you're doing debugging. However, most of the engineers might actually, you work with that and then you submit your firmware and then you realize, oh God, I forgot to turn this or this or this off. And UART can be one of those, or it's really common case. And for example, you can see here, we have the UART measured for this is actually in the yellow. You have without UART, and then duty cycle with. So what's the current exactly with and without UART? So what you will see here is in the corner that if we are looking now only at the active case, you would see that the without the UART, you will have maybe 3.23 milliamps is here, whereas with UART, you will have 3.3. So it's not much difference because we are looking at the active point of it. So here you would say, well, it's not making any difference. It's pretty good. It's fine. But then we go into this the kind of the world of sleep and the deep sleep. If you then check this specific measurement where we actually are measuring the current with and without a UART, and we're getting now with UART 62.9 microamps, and then without 2 microamps. So you see the difference. It's a huge difference. And since your device is in sleep mode, this will obviously cause a huge problem. And we actually calculated this, that in the case where you actually forget the UART to turn it off, you will have about 5 months of the battery life, whereas if you really have a firmware that is optimized and turned off this, you will have up to 6 years of the battery life. So simple things like that, and there are many more of that, like especially, like I said, in the microcontroller, there are a lot of things that might be hanging there, unused pins and so on, that you kind of have to turn off. So those are that's it. That is very much about sleep, and there's obviously much more to dig in, but I think this is one of those typical cases.
But yeah, like eventually a device is like almost always in deep sleep mode. It's only waking up maybe a few times a day or once an hour to do some calculations and to send a message. So getting this sleep mode right is really crucial.
Yeah, so the majority of the time is spent in sleep mode, which means that that is where you have to put the effort of getting that sleep to be really good, right? And of course, what you need to also understand is the third practice that I was talking about is the fact that you need to pick the right energy source for your application. Now, if you know if you have been really good at mapping how the power consumption profile of your device works for different user cases, you will then also understand that you will need an energy source that matches that. And if you look at the batteries as energy source, you don't always get rarely you get a lot of information out of the data sheet. You get enough to kind of get for kind of normal usage, some kind of ideal usage. But if you really want to go into your corner cases or play a little bit with different firmware and different things, you will realize very quickly that it's not giving you the right information. So here is really, really important to profile your battery for the specific device and to monitor that throughout the development to see what has changed. And I mean, the battery manufacturers can help there, but for the profiling, you can actually do that yourself. So you can actually go to your battery manufacturer and say, well, this is what I'm seeing. Why I'm seeing, is that because of the chemistry of the battery? Is that because I don't know, have too high peaks and this battery is not really suited for this? Mm-hmm. So you need to be more involved in that, right? And energy optimizing kind of for the whole system, and not just saying, well, the capacity is this should do, and it fits into my device, so I'm fine. That is a kind of old way of doing it, and it's not really feasible to do it nowadays, because IoT space is about selling services on top of the devices, right? And if you can't provide a hygiene battery life, you will not be able to get, good sustainable business on top of that.
Yeah, so you say that actually choosing and selecting the battery, even though you're using maybe AA batteries or whatsoever, is still a vital part for your IoT device.
Yeah, absolutely. And it is vital that you also check different batches, that you have a second source, right? I mean, if you have checked, for example, for a battery and you have tested and you're really confident with that, and then somehow during this lifetime of your device, your customer goes and changes the battery and picks another type of another brand, that actually might be an issue because you haven't tested for that specific brand. And even though they are kind of same type of the battery, they are not the same type of battery. They're not the same batch. So you really need to make sure that you have covered normal and these corner cases. So you don't end up in having those issues on the field or with your customer. They're not going to be especially happy if they realize that they, by changing the battery, have ruined something.
Yeah, exactly. Yeah, and this testing is really important because we cannot, like, if you develop a new device and put it to the market, like, you never know how it's going to operate exactly, because you cannot test for 5 years and only then put it to market. So you can never wait until the end of the lifetime.
No, you can't, but there are ways to speed it up. I mean, this is one of the things that we're doing with our tools, that you do kind of a calculated ways of speeding up these profiles, so you can, in a much shorter period of time, say a month, get with a certain accuracy or inaccuracy, but still better than just data sheet. You can get the notion of, like, what is it, how is it going to really perform? And I mean, this is the same thing that the battery manufacturers are doing. They can't really, if you go to them, they will not check, they can't do 5 years. They are still making an calculated assumption, I would say, from the experience and from these ways of profiling the batteries in a kind of speed up way.
Yeah, exactly.
Yeah.
Really interesting. So it's engineering your application, it's engineering your specific sleep, deep sleep mode, and eventually make sure that you really analyze the battery that you're going to use. invest in
Yeah,
that part.
picking the energy source. Even if you pick the energy harvesting, it's still the same thing. You still need to energy optimize. So you really need to make sure that it's efficient. There's efficiency in it. So picking the right energy source, absolutely. So those are kind of the three practices that you kind of need to have in mind when you are working with it.
Yeah, okay. Great, very clear. So if people want to get started with your tools, like where can they get started? Where should they go?
So I think they should go definitely to our webpage and book a demo. It's koitech.com, and you have the, the name above. It's very obvious. Book a demo. We can show you how the tool works. There's a lot of different technical papers that shows you how it works. There are, I'm guessing, Lawrence, you're going to be linking to some of the spreading factor papers that we have been doing, that people can learn much more about those specific topics. So yeah, I would say when it comes to engineering and for low power, come and talk to us, and don't forget and underestimate the fact how much knowledge there is with maybe your fellow firmware developer or hardware developer. Ask them. They have probably seen most of the stuff. And don't underestimate the fact that this is a kind of a system level approach, which means it's a hardware, it's a firmware, it's a software effort to get this running and getting that kind of low power and long battery life.
Yeah, good to understand. Great. So thanks a lot for sharing these insights. Is there anything else, any recommendations or advice you want to give the students?
I would say low power mindset actually starts with them now, especially now students. It's a new generation. I think when I studied and when my fellow electrical engineers studied this was not really a topic. And I think this is really changing. I think they can be kind of a first generation that has this kind of bringing this from the university into the workplace, and not just learning it 10 years later. So I kind of have really high hopes that they will embrace this kind of mindset and learn and be experts on it, because I think in 5 and 10 years, this is something that you just will be a hygiene. You just have to know how to do it. You can't just have one expert in a company. Everybody needs to be really good at this. So keep learning and measure every day.
Measure every day. All right.
Yeah.
Thanks a lot, Vanya, for sharing these insights. I think this is super useful. So I'm going to share some further resources. If you're interested to learn more, I'm going to add this below the video. And thanks a lot for sharing your insights.
Thank you for having me. All right.
All right. Bye-bye.
Bye.